Thank you, and thanks for Cranfield for asking me to come and speak here. So in terms of what I'm going to speak to you about, I'm going to tell you a little bit about Flogas. Some of you will know us, some won't. I would place a bet that quite a few who do know us didn't know we did biomass. It's perhaps our best kept secret, but hopefully you'll learn more today. I'll give a bit of background and information on the specifics of the Cranfield biomass installation. And I'll also get into the business case for biomass, both now and also trying to look forward into the future, what the business case may be doing between now, next year, and beyond. So Flogas Britain Limited is a company which is part of DCC PLC. DCC are a very large London Stock Exchange FTSE 100 company. We're a very diversified business, but a very large proportion of our revenue is coming from distribution of energy and specifically fuels. So oil, gas, consumer products, as well as the renewable energy services that I'll talk to you about today. So we supply a lot of off-gas grid fuels, but very recently we've moved into mains gas supply as well. We also, I've been told, distribute all the Xboxes in the UK as well, so something that I don't get involved in. Just some examples of the gas products that we supply. So natural gas through the mains, cylinder supply, both direct to domestic and non-domestic consumers, as well as bulk commercial gas to public sector and private sector. In terms of biomass, we supply design and build installation services. We do supply biomass fuel, and we also provide service and maintenance. So in terms of the design and build services we offer, so predominantly biomass heat, we have supplied and we are expecting to supply combined heat and power in biomass to non-domestic customers only, so commercial, industrial, and public sector. If I move back to some of the discussion a moment ago about the combined heat and power option in biomass, absolutely right, you can generate electricity. However, approach with care would be my recommendation. It can work, it does work, but unfortunately there are far more examples of where it hasn't worked. Particular areas that need to be considered in generating electricity are scale. It works best at very large scale. The technology, will it be bankable? Is the technology mature? Are there lots of reference sites and technologies that you can point to? And last but not least, efficiency. Electricity generation from any fuel, fossil fuel, never mind biomass, is not inherently efficient unless you're using the heat. Biomass tends to be rather inefficient. So it can work, but it's one to approach with care. We're spending a lot of time moving people out of oil boiler installations into gas, but also biomass as well. We're also involved in the biogas sector. We offer a technology, a gas upgrade technology, where we provide the propane enrichment and then the ongoing propane supply for a biogas plant which is supplying methane to the gas grid. Fuel supply I've covered there. A very big growth area for us is liquefied natural gas, which is essentially methane, so you can use the same infrastructure that you're using on natural gas, but it comes in a bulk tanker, so an off-gas grid solution, and very competitively priced currently. So I touched on the biomass. So that's probably most I'm going to say on the gas side. In terms of the biomass system we've got here, and that you'll see in a moment, it's a 990 kilowatt biomass boiler. It was commissioned in the winter 2014 and 2015, and it's serving the district heating system across the campus. Now, I think both Sam and Steve and Gareth mentioned the stringent testing regime. Whilst I was very confident in my engineering team and with my suppliers and the manufacturers, it was a challenging process, and I was delighted to see that we were delivering high efficiency performance at the range of different moisture contents. I've had the pleasure of working in the biomass world for over 20 years now, and as the previous speaker said, fuel quality is absolutely essential to success, and usually a biomass boiler system would not be able to deal with the sort of wet fuel that we threw at this boiler. So I was very pleased that we performed on the job, as it were, as opposed to in the brochure. So some of the features, it's been mentioned already. The top loader system was actually developed originally to move large volumes of compost around in the Dutch horticulture industry. In terms of biomass fuel store design and considerations, essentially what the ideal scenario to achieve is to future-proof your delivery. So you want to be able to receive deliveries from anything from a wheelbarrow to an HGV lorry. That gives you absolute flexibility in your fuel supply. But usually, the bigger delivery, the better. And I imagine LC Energy will mention this, but it's, if you can do a single drop of a full articulated lorry load, you're going to get the most cost-effective fuel delivery available in the area. But the top loader system developed and started to be introduced perhaps over the last 4 or 5 years in the UK. We, as Flogas and ClearPower subsidiary of Flogas, we've put in a number of these systems, and they came in essentially in response to the very high costs and potential ground engineering risks associated with underground stores. Underground fuel stores are tried and tested. They can work, they do work, and we do continue to offer that for specific sites in certain locations. But as someone mentioned this morning, when you've got 10 tons of fuel on top of your walking floor mechanism and you have to move it, and I've sweated bucket loads in a fuel store over the years trying to remove that. You don't want to be doing that if you can have an above-ground system that the top loader system offers. So if you have a problem with a mechanism, a motor broken, or any other issues, you can see it and you can get to it. So very important. So I'd compliment Cranfield in terms of the way they shifted to a more a different system, the top loader system, but also right from the start, their advisors were telling them, let's future-proof our fuel supply, rather than going for a lower capital cost investment. You need to have the space, you need to have the availability of capital, so it's not right for everywhere. But for a scheme of this sort, which is using significant volumes of fuel, this sort of delivery and storage mechanism really works. The boiler, it's manufactured by a company called Compt. Compt are a French boiler manufacturer. They specialize in commercial and industrial boilers. As you'll see, they're rather large boilers for their capacity. They're robustly built. They're heavy structures. They're built for long life and reliability. And as Sam has said, we were able to prove what their brochure is saying in terms of efficiency in operation. In terms of the features, there's a couple of features listed there, but really it's the high efficiency at the range of moisture contents, which I was particularly impressed by in terms of the specification, but then seeing the delivery. ClearPower Flogas have put in quite a number of Compt boilers across the UK, including at the Olympic Park district heating system in the northeast of England and in Scotland, and we were confident that Compt could deliver according to the performance requirements. And then particle size as well, so that's a function of the boiler, but also the fuel reception and transport and conveyor system. And again, the way this system was designed based on good advice from the team around us here, it allows it to accept large particle size. Because even when you have, you're specifying very small, you get occasional contamination, hopefully not quite as big as some of the ones we were shown there, but the ability to move those size of particle sizes around through a system it offers full flexibility. So, speaking more broadly about the opportunity within biomass energy. So, it's a low carbon energy source. So it's low carbon as measured by the government in terms of the carbon reduction commitment or what is replacing that, as well as other emissions standards, both formal and informal systems. You can use biomass. Biomass is particularly suited to retrofit as a retrofit solution to replace fossil fuel-based heating and energy systems. But essentially, you can design a biomass system to supply almost any energy demand. But if you speak to an experienced biomass installer, they can pretty quickly give you an idea of whether or not a project will work or not. I think myself and the rest of the Flogas biomass sales team, we normally know within 15 minutes of a conversation on the phone or a site visit whether or not biomass is going to work. Could be space constraints, could be the attitude and the appetite of the customer. I was chatting with someone this morning, and biomass energy, biomass systems do require more operational input than gas or oil. That's a fact. We can't get away from that. We as an installer and as a supplier, we like to be open about that. But if it's managed effectively, if the communication is there, then it can be dealt with and accommodated within most non-domestic settings. What is also quite interesting, and this site and this development is an example of it, is where biomass can form part of an overall energy supply strategy. And here you've got gas combined heat and power complemented by the biomass, and we're increasingly working on projects where we're looking at gas CHP and biomass. Tend to be for larger sites with larger consistent heat demands, but it's moving away, and I'll get on the next slide, moving away from what has been the RHI and the biomass world in the last 4 or 5 years has been characterized by biomass only, and there will continue to be biomass only without a doubt, but there's a move towards larger biomass schemes, the reasons for which I'll explain. But it's been a great success story in terms of the UK government's renewable energy strategy. 13,500 certified boilers, over 2.2 gigawatt of installed capacity in renewable heat. So some fairly impressive numbers, and we do have a biomass sector. Go back 10 years, the UK couldn't be said to have any really significant biomass sector, so it's very exciting to be in this position now. What comes next? Well, I've got a slide explaining my thoughts on that and some of the proposals, but I think it's going to be interesting, there's no doubt about it. So biomass is supported by, in terms of the business case, two factors. In certain oil price scenarios, biomass fuel can be cheaper than the fossil fuel alternative. Currently, sometimes it is, sometimes it isn't, but as you can imagine, when oil was at $110 per barrel, biomass was looking very competitive against fossil fuels. It still is competitive if you get the right fuel at the right price, usually in bulk quantities, but clearly that's not the same with oil at $38 a barrel. But the big driver of the business case is the renewable heat incentive. So that's a revenue-based support mechanism which came in 2011-12 to replace what was a very sporadic stop-start grant-based capital support mechanism, which was a nightmare, basically. working on behalf of clients to develop projects where you were chasing a grant rather than looking at what was right for your business and for your energy supply. So it's been a great success, but a consultation was launched about a month ago, and they're looking to make changes. So they've introduced a budget cap mechanism, but don't panic, we're unlikely to meet those budget caps at the current rate of deployment or even at an increased rate of deployment, as far as I know. There may be some in this room that know better, but as far as I know, I think we're fine for some time now, simply because biomass schemes have a long lead time. You can't, unlike solar, you can't install systems in a 4-week window, as we did many in December last year. But what they want to introduce from April 17, or they're proposing as part of their consultation, is a single tariff for all biomass systems. Currently, there are 3. If I go to the next slide there are 3 sizes. So you get a different biomass support tariff depending on the size of your boiler, the installed capacity, so the nameplate capacity. Now, some sobering numbers there for those of us who've been in the biomass world for some time. Small biomass, which is below 200 kilowatts, Tier 1, and I'll get into that in a moment, but Tier 1, you're getting 3.76 pence per kilowatt hour generated. So the government, so DEC via Ofgem, will provide you with 3.76 pence per kilowatt hour generated and recorded on a eligible heat meter. You go back 18 months, that was 8.8 pence. So that's reduced quite significantly. But when it was around 8 or over 8 pence, that led to many thousands of 199 kilowatt boilers being installed, many of which have worked well, some of which haven't, but no more on that. But what you can see is the small biomass has dropped dramatically. The reason why it was supported more is because scale does matter in biomass. There are economies of scale. As you'll get a sense of when you see the installation here, if you have a larger scale installation, the cost per kilowatt will go down typically, but more importantly, the capital cost per kilowatt hour supply is likely to reduce as you get into a bigger scheme, so a larger boiler supplying a larger demand. But the business case ultimately is delivered, a strong business case is delivered through a large heat demand relative to the capital cost needed to serve it. So the scheme here falls into the medium biomass category, which is between 200 and 999 kilowatt. That support mechanism, or that tier, has not changed dramatically over the life of the scheme. Essentially, it's gone up with inflation during the RHI scheme. But the proposals on the right, you'll see that's going to have an impact on different sized schemes. So if they introduce a flat rate of around 2.5 pence for Tier 1, and then around 2 pence per kilowatt hour for Tier 2, that will have an impact on small biomass, but the small biomass sector has been turned upside down in the last 6 to 9 months as a result of the digression of the RHI tariff, and that will only serve to continue that. But in the medium size, you're talking quite a drop. So the message really is that for a less than 1 megawatt boiler, and you can serve a significantly sized energy demand, as they do here at Cranfield. From April 17, the business case will be affected, and it's unlikely to be as good as it is today. People in biomass business development are quite famous for saying there's never a better time to invest and install biomass. It is true, has been true for quite some time, but I think it's quite sobering to see the proposals for post-April 17. But on the plus side, there could well be a positive impact on schemes above a megawatt capacity. So again, scale does matter, and we're speaking to a lot of industrial customers who were perhaps not the early adopters of the 199 schemes, but they've got demands of 2, 5, 7 megawatt of heat demand, and those are likely to continue to be supported quite strongly by the RHI. And I should say that, as announced at the beginning of December last year, it was a nice early Christmas present for those of us in the biomass world, the announcement of continued 5-year budget for the renewable heat incentive, which was quite a relief, really, considering at Flogas as a business and Flogas Renewables, we'd built quite an interesting solar PV installation business, but suffice to say, we're not too busy on that anymore. So just moving on beyond the RHI, and that the tiers are based on the number of run hours at full capacity. I can talk to any of you later to go into the detail of that. It's rather a dry subject, but it's very important when preparing a business case. So here are some numbers, completely anonymized. They're based on recent projects we've delivered, but also projects that we're currently in design phase and proposal phase. So in terms of the moving parts of the business case, as I said before, the heat demand is a big part of it, because the renewable heat incentive pays you per unit of heat delivered. Eligible heat has to be used properly and according to the criteria set out in the RHI regulations. But also, as you would imagine, your return on your investment on a retrofit situation, you're usually comparing it with a fossil-fueled scenario. And what price should we put in for oil? Well, there's a question. Currently, an industrial customer might be paying 20p a litre, whereas someone 5 miles down the road might be paying 40p. I remember the heady days when oil was 65, 70p a litre. Who knows where it's going to be when you're projecting out 5 years, 10 years. But when you're preparing a business case and an installer or a consultant will work with you on your business case, you need to have a cost for comparison. I should say, if you're standing there and you've just got a quote for oil at 20p per litre, and you say, well, I'm sure oil will be 20p a litre for the next 20 years, so if it doesn't wash its face there, then things may be difficult. But if in this comparison here, you've got a boiler similar size to this, but supplying either an industrial demand or a district heat demand of 5 million kilowatt hours, perfectly doable. That is a large, consistent demand, without a doubt. The capital cost, £700,000. You can pay less than that, but that's for a quality system, but not for, you can't connect 100 buildings for that, so that will increase the capital costs beyond that. So the sort of payback that you're looking at in simple terms is sub 5 years for that, and that's with oil at 35 pence per litre. 35 pence is below the 5-year and I believe the 10-year average for oil price. Projecting forward, do you think it'll be 35, 45? Well, that's something for the end user to consider taking advice. But if you do hit on a number that's right, please let me know. In terms of the larger scheme, just to show, even with, these are on current RHI tariffs, so I should say that's with RHI at 5.18 pence per kilowatt hour for tier 1 for the 990 kilowatt boiler. So that's current. And then going again at current, just over 2 pence per kilowatt hour flat rate for the larger boiler, supplying a bigger demand. That's like to be either a process steam or industrial hot water supply. Again, you're talking sub 5 years payback, which, yeah, some businesses work on a 1-year payback return, which is quite difficult to achieve. Saying that, in the days of the 2199 boilers for 50 quid, then sub 1-year paybacks were floating around. I doubt any of them actually were delivered on those offers. So just to finish off, just some examples of clients. So either Flogas or ClearPower, ClearPower being part of the Flogas group. We've done quite a lot of projects. We've done some smaller projects, but we're specialised in larger schemes, so megawatt boilers and beyond. That's a hospital up in Inverness. It's supplying nurses' accommodation, so 17 nurse accommodation blocks, so quite a lot of district heating up there. That's the London Olympic site, so the King's Yard, an enormous district heating scheme, and part of that heat supplied through a 3.5 megawatt biomass boiler. Not far from here in Northamptonshire, Castle Ashby is a large country estate and village, and there's over 70 buildings connected to a district heating network. And that's me, and more than happy to talk about your specific projects and